Welcome to our Common Core cohort. This is session number 2. I'm Daniela Fountain, and we have Sarah Cacciatore, curriculum coordinators here at Troy. Just a friendly reminder that those of you who are interested in receiving board credit will need to go online and submit for approval through our HR website. We'll also continue to post things, all of our materials and conversations, to our WebQuest under our Zoonal account.
Our parking lot is going to be rather 21st century this round. We will be having any teacher comments or group member comments facilitated through todaysmeet.com/ccs2. And although you're watching this as an audio recording, we do have comments that were posted throughout that meeting. This is a free site you can access through your smartphone, and you're welcome to take a look at that to use for a meeting of your choice.
Our goals for today are to learn about the instructional shifts in math, as well as the instructional shifts in ELA, specifically text complexity, literature, and writing changes that come with the Common Core state transition. We'll first start with the 6 instructional shifts in math, and you'll notice on the screen in front of you that the top 2 have stars, and some of the experts have said that these 2 areas, focus and coherence, are the largest shift that we'll see when we move from our state standards to our Common Core state standards across the nation. The first shift in math is that of focus, and we can really break this shift up into the teacher's focus as well as the student's focus. What you see on the screen in front of you comes from the PARC content frameworks. And what that is a way that they've developed priority standards in which students are expected to master. So this helps teachers focus on those key skills that are specific to their particular grade level. You'll notice the major clusters as well as the supporting clusters. And what PARC has decided to do is identify these so that teachers know which areas are the areas of most need for those students. One of the benefits for teachers focusing on particular standards is that they almost use the power of an eraser and narrow down and deepen the scope of how much time and energy is spent in the math classroom, which really supports the whole theme of the Common Core state standards, to go deeper rather than covering an abundance of skills. When we think about students and their focus, it's necessary for students to have focus so that they have enough time or sufficient time to think, practice, and integrate new ideas into their growing knowledge structure. It also allows time for the kinds of rich classroom discussion through math chats and interaction that support the standards for mathematical practice.
The second math shift is coherence, and really principals and teachers do this already. They carefully connect the learning within and across the grade level so that there is that sense of what we call vertical articulation. For example, fractions or multiplication spiraling across the grade levels so that students can build new understanding on foundations from the previous school year. Teachers really can begin to count on that deep conceptual understanding of the core content, and rather spending the first 2 weeks reteaching what should have been done the last year, they can hit the ground running and really build on that sense of mastery that the students have accomplished before. Each standard is not a new event, but an extension of the previous learning. Looking at the learning progression on your screen, you can see that this would be an example of how this would play out across multiple grade levels. Looking at fractions, for example, the skills build on one another so that you're constantly reinforcing that sense of mastery from the grade level before and then extending their knowledge further and further ahead.
The third shift is fluency. And when we think about what the Common Core state standards are expecting our students to do, they have very rigorous expectations, and it's not enough for students to learn procedures by rote, nor enough to just say that they are understanding concepts. Now we must have students apply concepts in order to solve problems. So that is where fluency in attaining skill comes into place. Students are expected to have that speed and accuracy with simple calculations so that teachers can structure their class time or homework or review more so on expecting students to be fluent so that they can start to apply and manipulate more complex concepts. You'll see fast and accurate at the top there, and that is how the Common Core State Standards refer to what the definition of fluency means in math. When you see the second bullet of expectations that represent culminating mastery, that truly is Park's definition of fluency, and that there are fluency standards because they stress the need for teachers to provide sufficient supports and opportunities so that students can practice and meet these expectations in order to get to the application point.
Taking a look at deep understanding, which is the fourth mathematical shift, it's really more than just the teachers helping students get to the right answer. It's about the teacher being able to have students see that there's more than just a set of mnemonic devices that students need to memorize in order to understand math procedures. It's really demonstrating that conceptual understanding of core math concepts by applying them to life situations, as well as writing and speaking about their understanding. The clip you're about to see is kind of a demonstration of that although the people who are modeling the math facts are able to articulate their point of view, it's really because they have a lack of math understanding or those core number sense concepts that they continuously get to the wrong answer. Take a look.
I figure 75% to you, Panma, and 25% divided between the 5 of us. Yida, Crowbar, myself, Tom, and the baby. That makes 5% for each one of us.
Billy, you're cheating yourself. If there's 25% divided among the 5 of you, that's 14% apiece.
Oh, no, listen, Pa. I wouldn't cheat you. You know I wouldn't. Now, look here. I'll show you. Let me rub this out here. And now, 25 divided by 5 is 5. You see, 5 won't go into 2, will it? No. But 5 goes into 25 5 times, you see?
No, you're wrong, Billy. Now, I'm a pretty good mathematician. Now, 5 into 25, 5 won't go into 2, will it?
No.
But 5 goes into 5 once. Now, we didn't use the 2 before, so we bring it down here. Now, 5 into 20 goes 4 times. There you are. 5 into 25, 14.
No, look, Pa. Let me prove it to you now by multiplication. 5 times 5. 5 times 5 is 25.
Really, I'm surprised you're learning.
Huh?
I'm surprised that you're learning. Now I'll show you. 5 times 14 is 25. 5 times 4 is 20. 5 times 1 is 5. 25. That's it.
No, look, Ma. Look, you're wrong there because I'll prove it to you. We'll put down 5 14s here. 14. There. Now I'll prove to you by addition that 5 14s is not 25. 4, 8, 12, 16, 20.
21, 22, 23, 24, 25. There you are. Better brush up, Billy. I don't want to see you boys cheated.
The fifth math shift is applications. And we spoke a little bit about this when we talked about the importance of fluency and how it relates to having students apply their math. With the Common Core Standards, students are expected to use math and choose the appropriate concept so that they can apply it even when they're not prompted to do so. Teachers are going to now provide opportunities at all grade levels so that students apply math concepts in real-world situations. Content areas outside of math, particularly science, will ensure that students are using math at all grade levels at all content areas to make meaning of and access variety of content. When you look at the question that's posed at the front there, you'll see that it says that Wikipedia reports that 8% of all Americans eat at McDonald's every day. In the U.S., there are approximately 310 million Americans and 12,800 McDonald's. The average McDonald's store can serve 1,500 people a day. Now look at the question. After students have read the variety of facts, now they must take a look at the question and use mathematical arguments to justify their position. This really supports the application shift.
Looking at dual intensity, which is the last mass shift, students are having to practice both of these skills simultaneously. It's more than just a balance between these two things. They're both really occurring with the same level of intensity. Teachers need to create opportunities for students to participate in those drill activities and make sure those skills are thorough in terms of their extended application. And you also need to make sure that you have the same amount of time and energy spent practicing and understanding within those learning environments by specific math concepts. So really, you're giving a nice equal variety throughout the school year of drilling that skill and applying it in life situations.